Hello, good morning students, and welcome back to another video for the exercise of the laws of motion chapter. Let's continue with the exercise, and the first question today is: an automotive vehicle has a mass of 1500 kilograms. What must be the force of vehicle and road if the vehicle is stopped with a negative acceleration of 1.7 meters per second square? So it's a straightforward question. You have been given mass and you have been given the acceleration. The only thing is that the vehicle is stopping and it is said that it is negative acceleration. So you have to use acceleration with the minus sign. Just find the force. Simple. F is equal to m into a, where m is 1500 kilograms, already in kilograms, so no need to convert, and acceleration is minus 1.7 meters per second square. Simple multiplication. 15 into 17 will give you 255. Okay, and 2 zeros and 1 decimal point. So place the decimal point counting from the right side. And as you can see, what you have the final answer as 2550 newtons. Of course, we have the negative sign. Don't forget this. Negative minus 2550 newtons. Very simple. Okay. Now the next one is a small MCQ. What is the momentum of an object of mass m moving with the velocity v? So you have been given mass and you have been given the velocity. And what is the momentum? Momentum is simple. We know the formula that P is equal to m into v. You have been given four simple options. First one is m square v square. That's the wrong answer. Mv square, again wrong answer. Third one is half mv square. Okay, again wrong answer. And the last one, m into v, because momentum is defined as the product of mass and velocity, not the product of square of mass and square of velocity, or product of mass and square of velocity. It's not like that. Simple product of mass and velocity. So the correct answer is fourth one. Okay. The next one, again we have a theoretical question. Using a horizontal force of 200 newtons, we intend to move a wooden cabinet across a floor at a constant velocity. So we have a cabinet and we want to move it, okay, across the floor, and the force applied is 200 newtons. The question is, what is the friction force that will be exerted on the cabinet? So we know that whenever an object is stationary and we apply a force, there is always a static friction that tries to stop the object. So over here, if we are applying the 200 newtons of force, then the static friction is also applying back the 200 newtons of force to stop the object from moving. Okay, so static friction always balances the force applied, and therefore 200 newtons will be the force of friction, but in the opposite direction. Okay. Quite simple. So imagine if this is the cabinet and you are applying a force over here 200 newtons, then friction force is also applying in the opposite direction 200 newtons, so as to balance out and the cabinet does not move, it remains stationary. Okay, but it all depends on the surface of the surface on which you are keeping the cabinet as well. Suppose the surface is quite smooth and the maximum static friction that can be applied with the surface is, let's say, 150, then 200 newtons will be enough to push the boat. So once the friction and the force applied, they balance each other out. After that, even a small force can move the object. Okay, so that's quite easy. The answer is 200 newtons. Okay, and now a numerical. Two objects of mass 1.5 kg each are moving with the same velocity. Okay, so we have two objects of mass 1.5 kg each. So both have 1.5 kilograms on a same line in opposite direction. So they are coming towards each other. Okay, towards each other. They have the velocity of 2.5 meters per second. So once again they have same velocity, and that is 2.5 meters per second. Before the collision. So before the collision. Now what is the question? So what will be the velocity after collision if they stick together? So what is happening is, let's draw a small diagram to understand this. Suppose this is an object, this is another object. This is moving towards this one, and this is also moving towards this one. So obviously the both are going to collide with each other. But the thing is, after collision they stick together. Okay, like the magnets we used to play, when they come together they are sticking together, and then you need to find the combined velocity of the two. So the mass of this one is 1.5 kg and this one is also 1.5 kg. They both have the same velocity as well. This is 2.5 and this is also 2.5. So both have same velocity, but after they stick together, we need to find the final velocity. So this is initial velocity, this is initial velocity, and we need to find the final velocity. And for that we have a very simple formula, that is the law of conservation of momentum. Okay, how do you use that? That is m1u1 plus m2u2 equals m1v1 plus m2v2. But because they are sticking together, the final velocity will be the same for these two, because both the objects are now combined together as one. They will be moving with the same velocity. So v1 and v2 will be same. So I can rewrite the equation like this: m1u1 plus m2u2 equals m1v plus m2v, because they both are the same. Now simply you need to substitute the values, that is m1 1.5 kilograms and u is 2.5, okay, plus m2 again 1.5 kilograms and u2 is 2.5 once again. But you know that this one is going in this direction and this one is in the opposite direction. So if you take this one as positive, then this one as negative, or if you take this one as positive, then this one is negative, because they both are opposite direction. So obviously one of the velocities will be taken as negative. So I am taking u2 as minus 2.5 is equal to 1.5 into v plus 1.5 into v, okay, because m1 and m2 are same. Once again, like over here on the left hand side, that is before the collision, m1 1.5, m2 1.5. okay, now when you multiply all this, you get 1.5 into 2.5 plus minus minus, because that's a multiplication. Obviously whatever answer you will be getting, that will be. Now as you can see over here, both the values are same, so no need to go into multiplication and waste your time, because whatever the answer is over here, that will be the same over here, and there's a minus sign in between. So obviously the calculation of all this is going to become 0. Over here 1.5 plus 1.5, you can take v common, so it becomes 1.5 plus 1.5 and velocity is common, and we know that 1.5 plus 1.5 is 3 into velocity. Now 3 goes that side in the denominator, so it becomes 0 by 3 equals v. That is, therefore v is equal to 0 upon 3 is any number is 0. So you get the answer as 0 meters per second. So once both the objects collide with each other, they will stick together and they will not move. Their velocity will become 0. Obviously because they both have same mass and they both have same velocity, so they both have same momentum. So after striking both the momentum, they will become 0. So the final velocity of both the objects is 0 meters per second. That's all for today, students. So today we studied 4 of the questions from the exercise. The first one was pretty easy, simple. F is equal to ma, multiplication, because it is already given in the question that it's negative acceleration. We use the acceleration as minus 1.7, simple multiplication, and finally you get the answer is minus 2550 newtons. That is the force of friction between the vehicle and the road. Okay. The next one is, what is the momentum? It is simple, P is equal to mv. Just choose the correct option, mv. And using the horizontal force of 200 newtons, obviously the static friction will also be equal to 200 newtons. So again, whatever force you apply, static friction will try to oppose, so you have 200 newtons. And the last one is using the formula of law of conservation of momentum. Okay, now listen students, this diagram that I drew over here is not necessary for you to draw, but it makes your understanding of the question much more easier. So try to draw that in rough work so that you can understand the question and then move forward. I hope it is clear to you, and we'll talk about more of the questions from the exercise in the next video. Till then, have a nice day.